Our presentation will be on climate warming, the increase in wildfires in the western United States. A brief introduction on this topic. It has been seen that over the decades, wildfires has increased tremendously and rapidly. According to NCBI, although it is believed to be mainly associated with climate change, it is also linked to lightning strikes in forest areas. Our article states that it contributes to a good amount of spending per year. Wildfires also causes significant damage to many homes and wildlife, releases harmful pollutants into the atmosphere, and causes stress on persons affected by its damage, according to UN Environment Program. Wildfires in the western United States became prevalent and gained more attention in the mid-1980s due to its sudden increase. Initially, it was thought to be caused by land use or climate change. However, Northern Rockies forests introduced the idea that it was due to climate change more than land use.
According to the text, the two main competing explanations for the current trend in wildfire activity are land use history and changes in climate during recent decades. In land use history, biomass accumulation following logging resulted in lowering the effectiveness of fire suppression. This also caused an increase in total area burned. In land use history, ecological restoration and fuels management could be a potential solution. Alternatively, in changes in climate during recent decades, an increase in spring and summer temperatures greatly affect increase in wildfires as well as an increase caused by earlier snowfall melting dates. In comparison to land use history, ecological restoration and fuels management would be ineffective in being a solution. Although these two are very different, a similarity is the increased occurrence of severe wildfires may be due to both heavy droughts relating to climate and to an abundant supply of fuels in some forests relating to land use. Essentially, this means that climate change in recent years affects the likelihood of live and dead vegetation to catch fire. The authors of this study used bolded headings that reformed the questions they had into topics. The study included multiple headings covering most all questions one may need to know. They neatly organized the topics into sections and included visuals such as graphs to support their claims and findings. The authors of this study used datasets and analyses to support their findings in numbers and graphs such as difference between the potential evapotranspiration due to temperature and the actual evapotranspiration constrained by available moisture. This proves that wildfire sensitivity was heightened in the months from October to September with moisture deficit. We used Stewart and colleagues' dates of the center of mass of annual flow for snowmelt-dominated streamflow gauge records in western North America. This showed that snowmelt directly affected the sensitivity to wildfires.
Okay, so this is the increased forest wildfire activity results section. From reading the article, I could conclude that there were massive wildfires increased throughout western forests, as well as the length of the fire in the mid-1980s. You can kind of see this in the graph on the right, along with the spring snowmelt correlation. Association is present between regional spring and summer temperatures, along with year-to-year variance between wildfire frequencies. The correlation coefficient is also 0.76, meaning that it has a very strong correlation because you can't get above 1. Also, wildfires increase in frequency in hotter areas. The time between discovery and control in the presence of a wildfire increased to approximately 37 days from 1987 to 2003. So what this is pretty much saying is that from the time that a wildfire is discovered, it takes a very long time to control the situation because data found that previously from 1987 that the control and discovery time was a lot shorter. Northern Rockies present a 60% increase in fires, along with showing similar periodic trends as the Southwest. This is pretty much saying that these wildfires come in kind of episodic episodes, which is how Northern Rockies and Southwest have a similarity. So this is the second part of the results section, fire activity and the timing of the spring snowmelt. I found from the document that earlier snowmelt dates correspond to increased wildfire frequency. Some statistics that back up this information is 72% of the area burned in wildfires, along with 56% of wildfires occurred in early snowmelt years. Only 11% of wildfires occurred in late snowmelt years. This is also present in the graph to the right, where it presents the frequency of wildfires is very high, almost 14 in the early years, and in late you can see that there's barely even 3. Also, the presence of spring snowmelt in the western United States mountains is strongly associated with spring temperature. So, this is also true that in warmer climates, there's more likely to be a wildfire. So, I think that's when it's talking about spring temperature, there's more likely a frequency of wildfires. Drier seasons result from an earlier snowmelt period, leading to a greater opportunity of large fires. So throughout seasons, drier areas looking like California and Washington in this graph, they have greater frequency of large fires. So the drier the climate is, the more likely there is to be a wildfire.
This is the third part of the results section, spatial variability in the wildfire response to an earlier spring. The data stated that the Northern Rockies and Northern California were the most vulnerable to changes in spring timing. Wildfires and temperature indicate to increase as elevation increased in the Northern Rockies. The moisture deficit in lower elevations are increasing, thus the summer droughts tend to be longer. The graph on the right indicates the areas where forests are most vulnerable based on the percent difference in potential evapotranspiration due to temperature and the actual evapotranspiration. The final analysis by the researchers concluded that there is a direct relationship between regional environmental response and climate change. The transition from short, infrequent wildfires to longer, more frequent ones occurred in tandem with the climate's shift towards longer, drier summers and thus drier vegetation.
The map on the left shows areas of California that are most threatened by fires between 2 tiers, elevated threat and extreme threat.
As mentioned before, the regions most affected are the Northern Rockies forests and the Northern California forests. The Northern Rocky forests are mostly affected because of climate change, and the Northern California forests are mostly affected due to mining and timber harvesting. This is important because the climate change increase causes wildfires, and more wildfires will cause the climate change to increase. This is also important because the snow will melt sooner in the winter, and this will cause warmer and longer summer and spring seasons due to the increased temperatures. The regional and global implications are there an increased risk of wildfires in already warm areas. Another one is that there is a higher global surface temperature which will cause wildfires all over the globe instead of just in the US. This cycle will also keep repeating itself and continue to get worse unless something is done to fix or change it.
So, wildfire reduction. In order to reduce the amount of wildfires in the United States, humans must be more careful in leaving campfires and burning of debris unattended. This is because 85% of wildfires are caused by neglect and discarding of flammable waste from humans. So, lit cigarettes just thrown on the ground, campfires just let gone, didn't really snuff them out. This has to, as humans, we have to work on this to fix this, because if we don't, wildfires are going to continue, and at the end of the day, it's not going to be solved. We're not going to reduce the amount of wildfires. Another way to do this is by the reduction of global warming, which is caused by ozone layer. When the ozone layer is thin, temperatures begin to increase due to global warming, and the rain kind of just evaporates, isn't there, so it can't really cool it off. So these two things, making sure our fires are put out when we're camping or where people are smoking, whatever, we have to make sure that's taken care of. And as a whole community, we all have to work on our ozone emissions. So one way wildfire aid can be helped is by donating to the Red Cross. Red Cross makes sure that not only the people that are affected by these wildfires, but the animals and the landscape or the wilderness that is affected by this wildfire can get the help it needs. And not only that, but it can overall benefit from just their overall community support. Another way is just by donating time. If you're living near somewhere that's been impacted by wildfire, just donate some time, some resources, food, water, shelter to people that may have been displaced. Or if it's an animal, make sure that it's taken care of. If it can get to a vet, or it can get to maybe a sanctuary for it. Just making sure that all people are safe. So if we combine our efforts in this aid, I feel that not only when wildfires happen will they be less harmful to the environment because they are a natural disaster, but they will also lead to better community response and overall preparedness for these type of events.